Hey everybody. As, as for why I have my shirt off and I'm all wet? No, well, I'm sweating. It's so hot outside. That's why I have the shirt off for a second. And speaking of hot, that's what we're gonna be talking about today. So fasten your seatbelts because today day is
International Day for the Preservation of the Ozone Layer, 16th September. What is International Day for the Preservation of the Ozone Layer? Vienna Convention for the Protection of the Ozone Layer. The scientific confirmation of the depletion of the ozone layer prompted the international community to establish a mechanism for cooperation to take action to protect the ozone layer. Montreal Protocol. The principal aim of the Montreal Protocol is to protect the ozone layer by taking measures to control total global production and consumption of substances that deplete it. With the ultimate objective of their elimination on the basis of developments in scientific knowledge and technological information. The Montreal Protocol is structured around several groups of ozone depleting substances. The groups of chemicals are classified according to the chemical family and are listed in annexes to the Montreal Protocol text. This was formulated in the Vienna Convention for the protection of the ozone layer, which was adopted and signed by 28 countries on 22nd March 1985. In September 1987, this led to the drafting of the Montreal Protocol on substances that deplete the ozone layer. In In 1994, the United Nations General Assembly proclaimed 16 September the International Day for the Preservation of the Ozone Layer, commemorating the date of the signing in 1987 of the Montreal Protocol on substances that deplete the ozone layer. Thank you. Have a happy International Day for the preservation of the ozone layer.
Building your business online takes effort, and when it's ready for the world to see, that's where Google Ads help.
Yep, that's right, people. Today is the International Preservation for the Today's the International Day for the preservation of the ozone layer, and not just any time. It's the 35th anniversary. So,
this year, we celebrate 35 years of the Vienna Convention and 35 years of global ozone layer protection. Life on Earth would not be possible without sunlight. But the energy emanating from the sun would be too much for life on Earth to thrive were it not for the ozone layer. This stratospheric layer shields Earth from most of the sun's This stratospheric layer shields Earth from most of the sun's harmful ultraviolet radiation. Sunlight makes life possible, but the ozone layer makes life as we know it possible. So, when scientists working in the late 1970s discovered that humanity was creating a hole in this protective shield, they raised the alarm. The hole caused by ozone-depleting gases, ODSs, used in aerosols and cooling, such as refrigerators and air conditioners, was threatening to increase cases of skin cancer and cataracts, and damage plants, crops, and ecosystems. The global response was decisive. In 1985, the world's governments adopted the Vienna Convention for the protection of the ozone layer. Under the convention's Montreal Protocol, governments, scientists, and industry worked together to cut out 99% of all ozone-depleting substances. Thanks to the Montreal Protocol, the ozone layer is healing and expected to return to pre-1980 values by mid-century. In support of the protocol, the Kigali Amendment, which came into force in 2019, will work towards reducing hydrofluorocarbon, HFCs, greenhouse gases with powerful climate warming potential and damaging to the environment. World Ozone Day, held on September 16, celebrates this achievement. It shows that collective decisions and action, guided by science, are the only way to solve major global crises. In this year of the COVID-19 pandemic that has brought such social and economic hardship, the Ozone Treaty's message of working together in harmony and for the collective good is more important than ever. The slogan of the day, Ozone for Life, reminds us that not only is ozone crucial for life on Earth, but that we must continue to protect the ozone layer for future generations.
as you can see right there, please stand by for a second. Okay, nice background, huh? Very beautiful, huh? Anyway, let's get started with this video. Now, what is the ozone layer and the importance and preservation of the ozone layer? Well, that's what we're going to find out. What the ozone layer is.
Every year, 16th September is celebrated as the International Day for the Preservation of the Ozone Layer. The theme for this year's Ozone Day is Caring for All Life Under the Sun. Ozone Day marks the date of the signing of the International Under the Sun.
This one's 2017.
Ozone Day marks the date of the signing of the International Montreal Protocol, which was signed in 1987 to phase out the production and consumption of ozone-depleting substances. These substances generally contain chlorine, fluorine, bromine, carbon, and hydrogen in varying proportions. Some other substances such as chlorofluorocarbons, carbon tetrachloride, and methyl chloroform are human-produced ozone-depleting gases. In India, the National Ozone Center under the Indian Meteorological Department at New Delhi maintains and controls a network of ozone stations, including MET3 in Antarctica. Ozone data is regularly sent to World Ozone Data Center at Canada for research and archival. So, what is ozone? Well, it is a colorless gas which is found in the stratosphere of the upper atmosphere. The layer of ozone gas protects us from the harmful ultraviolet radiations of the sun. Ultraviolet radiations are high-energy electromagnetic waves emitted by the sun, which, if enters the Earth's atmosphere, can lead to various environmental issues, including global warming and other health-related issues for all living organisms. The ozone layer absorbs these harmful radiations and prevents them from entering the Earth's atmosphere. Around 90% of the ozone is found in the stratosphere. This region begins about 10 to 16 kilometers above Earth's surface and extends up to about 50 kilometers altitude. Ozone is created when the oxygen or O2 that we breathe is split apart by sunlight into single oxygen atoms. Single oxygen atoms can rejoin to make O2, or they can join with O2 molecules to make ozone or O3. Ozone is destroyed when it reacts with molecules containing nitrogen, hydrogen, chlorine or bromine.
मॉन्ट्रियल प्रोटोकॉल के तहत ये बाध्य था कि विकसित देश ज़्यादा कंट्रीब्यूट करेंगे, ज़्यादा एफर्ट्स करेंगे, प्रयास उनके ज़्यादा होंगे ओजोन लेयर को बचाने के लिए और क्लाइमेट चेंज के लिए भी। दूसरी चीज़ ये थी कि ये भी माना गया था कि जो विकासशील देश हैं, क्योंकि वो अभी प्रोग्रेस नहीं कर पाए हैं, वो देर में फेज आउट करेंगे। एक तो पहले फेजिंग आउट ऑफ CFC था, फिर फेजिंग आउट ऑफ HCFC था, अब फेजिंग आउट ऑफ HFC है। तो ये पूरी एक साइकिल ऑफ फेजिंग आउट ऑफ केमिकल्स है। तो इसलिए अब आज के दिन में अगर आप देखें तो ओजोन लेयर काफ़ी हद तक रिकवर हो गई है और ऐसे माना जाता है कि 2050 तक ये काफ़ी पूरी तरह से हील होने की संभावना है।
The ozone hole is the reduction in concentrations of ozone in the stratosphere. It is defined geographically as the area wherein the total ozone amount is less than 220 Dobson units. The ozone hole had steadily grown in the 1980s, but after the Montreal Protocol was signed, the ozone layer is now being restored. Chlorofluorocarbons CFCs have been replaced by hydrofluorocarbon HFC and hydrochlorofluorocarbon HCFC. It is utilized as a coolant in home appliances like freezers, refrigerators and air conditioners used in both buildings and cars and home manufacturing detergents. To help preserve the ozone layer, one should remove HCFC refrigerants from an appliance before it is disposed. Use fire extinguishers that do not contain halon, encourage growth of plants, discourage deforestation and decrease release of ozone-depleting chemicals. With aim to preserve ozone layer in March 2017, Indian government launched a phase-out plan for appliances using HCFC gas. It is necessary to be well aware of the benefits of the ozone layer. and the increasing need to preserve it. It is an umbrella that protects us all. So let's all pledge to preserve it for a better tomorrow.
I do. I do. Oh, and I like that.
Get ClickUp's.
Now we're going to learn about climate. Now we're going to learn about the ozone depletion. Climate 101.
Far above Earth's surface, the ozone layer helps to protect life from harmful ultraviolet radiation. Learn what CFCs are, how they have contributed to the ozone hole, and how the 1989 Montreal Protocol sought to put an end to ozone depletion.
"15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.
But that's up to you. Because if you use those any of those chemicals, then you're breaking the law and destroying the ozone layer. Because now you know how it works. And now you know how it works, and the science of how it works, which is very interesting to me. Which is very interesting. Which was very interesting, but now since we know, but now that we know how what depletes it and what depletes it, don't use it, because otherwise Otherwise, you'll be destroying the ozone layer and risking us getting getting serious sunburns, which could lead to skin cancer. Trust me, cancer is a very painful way to die. So don't do it, or else. And thank you, National Geographic, for the...
You might be surprised to learn the hole in the ozone layer has almost healed. Even more surprising? We actually fixed it with legislation. Here's how.
Which will after this ad.
Getting every nation on Earth to agree to an environmental issue is tough, but it has been done before. The Montreal Protocol on substances that deplete the ozone layer, or just the Montreal Protocol, is the most successful step we've ever taken to protect our planet. But getting there wasn't easy. When you hear about the ozone layer, you probably think of aerosol cans. But the story actually begins with air travel. In the early 1970s, jet setting around the world took off, pun intended. And curious scientists started gathering data on how all this air travel was affecting Earth's atmosphere. Ozone is a vital molecule of 3 oxygen atoms that exists mainly up in the stratosphere. It's very rare. There are about 3 molecules of ozone for every 10 million molecules of air. Still, those 0.3 parts per million of ozone play a critical role of absorbing biologically damaging UVB sunlight. At the time, ozone had been studied, but Frank Sherwood-Rowland and Mario Molina threw ozone into the spotlight. They posited that chlorine atoms from refrigerators and AC units might have an adverse effect on our atmosphere, and boy were they right. It turns out CFCs, or chlorofluorocarbons, can actually float all the way up to the ozone layer, and when they get there, the CFCs run rampant. Ultraviolet light breaks a chlorine atom off the CFC. That chlorine in turn breaks an oxygen molecule off of ozone and binds with it, until another free oxygen atom comes along and kicks the chlorine off onto its lonesome. That spurned chlorine then continues the cycle of breaking down more ozone molecules into oxygen molecules, and basically CFCs are serious home wreckers, and they were wrecking our home, planet Earth. The study called out man-made chemicals for contributing to the problem, and as you might expect, there was a backlash from the companies and people who made those chemicals. Because some of these were commonly used in refrigeration and air conditioning units, industry groups had a lot to lose and resisted any regulation. Industry representatives said it was unnecessary to take action against useful chemicals over what many felt was flimsy evidence. Gosh, that sounds so familiar. But the scientific evidence kept mounting, and a report from the National Academy of Sciences published in 1976 solidified the link between CFCs and the depleted ozone layer. So of course, everyone jumped to action right away and started... Just kidding, we waited till the problem got really bad. In 1985, researchers found the ozone layer over the South Pole had depleted by about 40% in just a decade. Even NASA hadn't noticed because the programs they were using were set to ignore what they assumed were just impossible ozone measurements. NASA ignored a giant hole because they thought it was impossible. Unable to ignore the problem any longer, 28 nations, including most of the largest CFC producers, finally signed on to the Vienna Conventions, establishing guidelines for negotiating international regulations on substances harmful to ozone. But it wasn't enough. About 2 years later, the Montreal Protocol was drafted. Designed to reduce the production and consumption of substances harming atmospheric ozone, it held signing nations responsible to gradually scaling back the use of nearly 100 different chemicals. The atmosphere-harming substances became controlled, and the protocol laid out a binding agreement to stemming their use. We were finally taking the environment seriously. Can you imagine that happening now? Can you? The treaty has been adjusted and amended a number of times since. It's also been changed to account for unforeseen side effects. Hydrofluorocarbons, or HFCs, were introduced as a chemical to take the place of CFCs in things like refrigerators and air conditioners after they became regulated. And while HFCs don't hurt the ozone, they are greenhouse gases that trap heat far more efficiently than carbon dioxide. Once that was known, a phase-out plan for HFCs was added into the Montreal Protocol as well. On September 16th of 2009, the Vienna Conventions and the Montreal Protocol became the first universally ratified treaties in UN history. Now, 30 years later, the results of the Montreal Protocol are very clear. The ozone hole over the South Pole is healing, plus a new study found an encouraging side effect: a significant drop in greenhouse gas emissions in the US. They found prohibition on these chemicals eliminated the equivalent of 170 million tons of carbon dioxide emissions annually, a level never anticipated by the original treaty. The team estimates that by 2025, the US will reduce greenhouse gas emissions by the equivalent of 500 million tons of CO2 every year compared to 2005 levels. The Montreal Protocol worked, thanks to the cooperation of all 197 signing nations. If history were to repeat itself, now might be a really good time. Global temperatures are still rising, but the Paris Agreement, designed to keep global temperature rise below the 2-degree tipping point, is facing some, shall we say, pushback from one signatory specifically. But if anything, the Montreal Protocol shows that if we pull together, we can make a global change that benefits everyone. Some countries are doing better than others in the fight against climate change. We did a video on whether China is taking the right steps. You can check that out here. Do you think it's possible to undertake another climate agreement like the Montreal Protocol in today's political environment? Let us know down in the comments, and be sure to like this video and please subscribe so you get more Seeker.
That's why it's now a war against oligarchyism and those who a war against those who want and the oligarchy and a war against the oligarchies who want to destroy our environmental regulations out of greed, which makes me sick and want to in their face. But that's illegal. But that's how I feel. But it's illegal to spit on someone. I would do it if it was legal. But it's not. So there. Now, before we move on, let's read more of this.
The Montreal Protocol is the most successful climate agreement ever. https://motherboard.vice.com/an_a/ar. In 1987, almost every country in the world signed the Montreal Protocol, agreeing on a plan to phase out damaging CFCs. Consumers bought in, too, voluntarily boycotting the spray cans. As a result of this global effort to get rid of CFCs, scientists now say the ozone layer is slowly healing. The hole in the ozone layer is at its smallest in nearly 3 decades. https://www.seeker.com/earth/climate. In 1987, the Montreal Protocol initiated the phase-out of these chemicals. As they gradually leave the atmosphere, the ozone hole will heal, and scientists expect it to return to 1980s size by 2070. Whatever happened to the hole in the ozone layer? https://www.seeker.com/what-ever-hap. Ozone is an allotrope of oxygen. 3 oxygen atoms linked together that occurs naturally in the atmosphere. The ozone layer isn't an actual layer, as such. The term refers to scattered ozone molecules floating in the stratosphere, anywhere from 6 to 30 miles overhead.
Well, there you go. I zoomed in so you can read it better. I hope it worked. But I only did it at the last minute, so I apologize. But we're gonna move on. Still a beautiful picture of the Earth, right? All right. Now for the protect ozone layer, save life on Earth. So we're gonna watch the video of preservation of the ozone layer. What is ozone layer? The ozone layer is a natural part of our atmosphere containing a high concentration of ozone. Why do we need to protect the ozone layer? The ozone layer is extremely important as it protects the Earth and its inhabitants from the dangerous... Wasn't done. David, the dangerous UV rays of the sun. Do you know? Our ozone layer is now being damaged and there are holes forming in the ozone layer. What causes the ozone holes? Man-made chemicals like CFCs, HCFCs, which are used in our everyday lives. Are damaging our ozone layer. Impact. The holes in the ozone layer mean that more UV rays would be reaching us. This can cause skin cancer, eye damage, impaired immune system, crop damage, marine ECO system damage. I think that's how you say it. Can we stop the damage? Yes, we can. All of us can contribute to the protection of the ozone layer. Any long trip begins with the first step. To spread awareness is the first step to protect our ozone layer. Any long trip begins with the first step. That's kind of similar to what Neil Armstrong said. That's almost kind of similar to what Neil Armstrong said. That's one small step for man, one giant leap for mankind. Kind of similar, don't you think? All right, let's continue. Encourage your parents, relatives, and friends to use products labeled as ozone friendly. Avoid buying canned sprays like perfumes, deodorants, hairsprays, etc. 3. Reduce the use of heating and air conditioning. 4. Use CFC-free refrigerator and air conditioner. 5. Choose a fire extinguisher which does not contain any ozone depleting substance. 6. Avoid liquid correction fluids that contain methyl chloroform. 7. Buy furniture that were not treated with pesticides. 8. Reduce the use of your car and of other gadgets gadgets like compressors, lawnmowers, etc. 9. Use alternate means of transport. Buses, bicycles, or simply walk. Walking is good exercise, but I advise not walking at dark, unless you're very taught in self-defense like Krav Maga, or have a self-defense tool like pepper spray, stun gun, or that kind of thing. Because there are predators out there. And I'm not talking about the animal kind. I'm talking about mankind. You know, the predators who attack people. The bad people. They mostly attack at night, more in the rather than in the day, because how should I put this? At night they're less likely to be seen. But anyway, moving on. 10. Reduce air travel. Which is kind of what I'm doing since I'm kind of scared. Which I'm kind of doing since I'm scared of flying. And I bet you're. And I bet. I don't. Tell me if you're scared of flying and why. Mine is because I don't want to die. I don't want to die. Since there are no. If you know what I mean. Tell me why if you're scared of flying, tell me why in the comment section below. Reduce air travel. 11. Use medical devices like inhalers that don't emit CFCs. 12. Suggest Alright, 12. Suggest school activities to increase awareness about the problem. 13. Sign petitions and write letters to leaders who make policies to care the ozone layer. Like flood people, like Trump and McConnell, Regan Biden. Those two definitely need an entire desk full of petitions to get. These small acts can make big impacts, so I'm going to go on and work on pressuring the ozone layer by encouraging everyone to save our sky. What about you? Thank you. By Hima and Joseph.
Created using Powtoon.
I wonder what Powtoon is. Now this video is by the UN Environment Program. The Whole, a film on the Montreal Protocol narrated by Sir David Attenborough.
Sir David Attenborough narrates the extraordinary history of the Montreal Protocol to raise awareness of the 28th meeting of the parties to the Montreal Protocol in Kigali, Rwanda, and efforts to control powerful global warming chemicals hydrofluorocarbons HFCs under the protocol. Reducing HFCs under the Montreal Protocol can avoid 0.5 degrees Celsius of global warming by the end of the century, while continuing to protect the ozone layer.
If the I'll be right back because I'll be right back, people. My throat's kind of getting a little dry. Much better. All right, let's continue. Let's start the next video.
Let me share with you one of the greatest success stories of environment negotiations ever. Indeed, it may be one of the greatest success stories of any sort of negotiations on this planet.
In our long history, there is one unprecedented act of humanity in which every country on Earth came together to protect the future of life on Earth. The Montreal Protocol.
The story of the Montreal Protocol is in some ways also the story of the 20th century. Something that was a great invention, namely a chemical chlorofluorocarbon, had unintended consequences that suddenly became a planetary problem.
It all began with a good idea. In the 1920s, coolants in refrigerators were so toxic that a leak could kill you. So we invented safer chemicals to do the job, CFCs.
The wonder chemicals of the 20th century.
They were so versatile, people's lives were transformed. But in 1974, Sherwood Rowland and Mario Molina predicted that the Earth's natural sun shield, the ozone layer, was being eaten by CFCs at a terrifying rate.
We felt a great responsibility to actually warn society that something could happen.
All eyes turned to the ozone layer. And sure enough, there was an enormous hole in the stratosphere.
It was such a shocking revelation. Over half the ozone layer destroyed above Antarctica in a decade.
If the destruction
above Antarctica.
That's the same. That's 1979. That's the same year that the Iranian Revolution happened. 1989, the same year that communism started to collapse. Sorry, I'm getting a little sidetracked, so...
Over half the ozone layer destroyed above Antarctica in a decade.
If the destruction wasn't stopped, we'd be at risk from lethal levels of UV radiation.
We'd be in dead trouble. We'll have a blind, burnt population.
Faced with this global threat, the world came together to take action. And in 1987, more than 30 countries agreed to phase out the production of CFCs and signed the Montreal Protocol. Over the 3 decades since, the rest of the world's nations have signed up. Together, they've taken on the greatest planetary repair job ever attempted.
It's absolutely terrifying to work on a project that's so important because you know that failure is not an option.
Making the Montreal Protocol a success has taken brilliant minds.
We are working to protect human life.
It has taken determination.
It has made more progress than any other environmental convention in the world.
If the countries of the world engaged in similar deliberations for every issue that faces our world, I'll be very happy.
And it has taken ingenuity from an extraordinary global community.
We always have our disagreement, and at the end of the day we have our agreement.
And it has worked. With CFCs banned, the ozone hole is healing. Now it's time to take action again.
You need passion, you need leadership to change the Montreal Protocol into an even better treaty. victory is within our grasp.
There's only one Earth. We have only one Earth to protect. We cannot lose this one.
Once more, we must come together to protect the future of our planet.
To you, the delegates, and as somebody who considers himself part of the Montreal Protocol family, as you meet in Kigali, look to history, remember where the Montreal Protocol started off from, and please help the world to take the next step. There is need for everybody to compromise, but sometimes out of small steps towards one another, big things can happen, and you, as a family of the Montreal Protocol, have demonstrated that time and time again.
Windfall Films, part of the. Yeah, that was a good message. I hope people like Trump and Biden are watching this. Thank you, Sir David Attenborough. Sir David, and he's one of the people that I want to meet before he's no longer part of this earth. So, Sir David Attenborough, legendary environmentalist. I wonder how he compares to Bernie Sanders in environmentally. I think those two should meet. But anyway, I'll be right back. I'll be right back as quick as a flash. BRB. Told you I'd be back in a flash. So, science works protecting the ozone layer. In this video,
Sir David Attenborough narrates the extraordinary history of the Montreal Protocol to raise awareness of the 28th meeting of the parties to the Montreal Protocol in Kigali, Rwanda, and efforts to control powerful global warming chemicals hydrofluorocarbons HFCs under the protocol. Reducing HFCs under the Montreal Protocol can avoid 0.5 degrees Celsius of global warming by the end of the century, while continuing to protect the ozone layer. How basic research helped scientists discover the effect.
Let's try that again.
How basic research helped scientists discover the effects of ozone-depleting chemicals in Earth's atmosphere, and led to public policy changes to protect and eventually restore it.
You can learn more at this website, which is not complete, so let's watch the video. But before we do that, hold the microphone. Okay. Ooh. Okay, I'm ready now. So let's get to it.
This video is a product of the Annenberg Public Policy Center's Science of Science Communication Initiative.
Science words protecting the ozone layer. Science.
This is a story about curiosity leading to research, and research producing huge benefits for the entire planet. Long before humans knew very much about the atmosphere, we were curious about the sky. Investigation of the air around us goes back thousands of years. Thunderstorms fascinated Homer in ancient Greece. In the Odyssey, Homer observed their sharp odor. He wrote, "The storm thundered and lightened, and the air was filled with sulfur." Homer didn't realize it, but he was actually describing chemical reactions that produce ozone. Ozone is a gas that has 3 atoms of oxygen in its molecule. It has a foul odor, and close to the ground, it is actually toxic. But lucky for plants and people and other living things, roughly 90% of the Earth's ozone is high in the sky, where it serves as Earth's sunscreen, protecting us from harmful UV radiation that comes from the sun. How do we know this? Because long after Homer pondered ozone in poetry, human beings began to investigate it through science. We've studied ozone on the ground, in the atmosphere, and even from space. And with this research, scientists predicted, found, and solved a dangerous problem with the Earth's ozone. Back in the 1880s, chemist W.N. Hartley was the first to figure out that ozone played a valuable role in the atmosphere. Ozone, he thought, must absorb some of the UV light as it passes from the sun through the Earth's atmosphere to us. In their day, Hartley and his peers could identify a few gases in the atmosphere, but most gas concentrations are so small, science didn't have equipment powerful enough to detect them. So the scientists got to work. In the 1920s, physicist G.M.B. Dobson invented a device that could measure small concentrations of ozone by recording the wavelength of light it absorbed. That pattern of light is called a spectrum, so Dobson called his machine a spectrometer. By 1948, Belgian scientists measured the infrared spectrum of air to show that another common gas in the atmosphere is methane. Every discovery made scientists more curious about the atmosphere, so they developed better and better tools. By the 1950s, they could measure 14 chemicals in the atmosphere. Analytical chemists continued to measure ever smaller substances, and today we can identify over 3,000 atmospheric compounds in the sky. Basic research made it possible for us to see what has been in the atmosphere all along. But it also revealed a serious danger. Here, let's go back to the ground. Since the 1960s, the world has seen a rise in malignant skin cancer that can be best described as alarming. Many factors have contributed to the rise: people moving and traveling to sunnier places, change in fashion over the years. We've literally exposed ourselves to more sun. But scientists also suspected that some of the Earth's sunscreen, ozone, would disappear. A decrease in ozone would let more of the harmful UV rays from the sun reach the surface of the Earth, and that would push rates of skin cancer even higher. But if the ozone continued to decrease, more harmful rays could also lead to an increase in cataracts, damage our immune systems, and make it harder for plants to grow. And the problem was getting worse, because as scientific discovery was advancing in the 1960s, so were other technologies much closer to home.
Wow, that door's got ice coming out of it.
Refrigerators preserved our food longer. Aerosol sprays made our rooms smell better. They made people smell better too.
When you're tense and rushed, it's time to try new dial deodorant.
Styrofoam and similar products made things easier to ship or carry. And air conditioners made it possible for us to live in sunnier, hotter places. But in all of those things, we used a minute chemical with a very big name: chlorofluorocarbons, or CFCs for short. Okay, now look up again. As our ability to discover all of those chemicals in the atmosphere grew, in the early 1970s, British chemist James Lovelock detected CFCs in the air. He found them blowing east from big cities over Ireland, which made sense. More CFCs would be used in cities because there are more people there. So Lovelock put his detector on a ship and found CFCs in every one of the more than 50 samples collected in the North and South Atlantic. Lovelock concluded that CFCs from industrial areas traveled far and wide around the globe. All of these CFCs traveling in the air prompted future Nobel Prize-winning chemists F. Sherwood Rowland and Mario Molina to ask a very important question. What does it mean to have large quantities of CFCs in the atmosphere? First, these two chemists showed that at lower altitudes, CFCs could stay in the atmosphere for decades. They were virtually indestructible. But when they reached 18 miles above the Earth, harmful UV rays would break the CFCs apart into chlorine atoms and residual fragments. Other research showed that chlorine breaks ozone apart, forming chlorine monoxide. And that is part of a chain reaction that is absolutely devastating. A single chlorine atom can destroy 100,000 molecules of ozone. So every time a CFC compound broke apart in the ozone, the chlorine from it destroyed the Earth's protective sunscreen. And industry was releasing 1 million tons of CFC into the atmosphere each year. In 1974, Rowland and Molina predicted that, at that rate, atmospheric ozone would drop 7 to 13% by 2050. So they called for a ban of all CFCs. And just 4 years later, the United States listened to the scientists and banned the use of CFCs in aerosol sprays for hairspray, deodorants, and other products.
No.
Canada,
No.
Norway,
Nein.
and Sweden did the same. And then scientists discovered that actually, the problem was many times worse than they thought. At the end of the 1970s, British scientists, followed by Japanese and American researchers, showed that levels of ozone above the Antarctic were dangerously low, as much as a third lower than averages measured only a decade before. People all over the world began calling it the Antarctic ozone hole. Each discovery was another problem begging to be solved. This is atmospheric chemist Susan Solomon in Antarctica. In 1986, Solomon and several of her colleagues showed that elevated levels of chlorine monoxide in the atmosphere above Antarctica was causing the ozone hole. Flight data the next year proved them right. Chlorine monoxide from CFCs was devouring ozone above the South Pole. The evidence showed that the Earth had a problem, and the world responded. In 1987, 26 nations and the European Union signed the Montreal Protocol on substances that deplete the ozone layer.
All nations gathered here can be proud of what we have achieved.
They agreed to limits on the production and use of gases that deplete ozone. Besides CFCs, these included methyl chloroform used in solvents and bromine chemicals from fire extinguishers and pesticides. It called for a complete ban on CFCs in developed nations by 1996, and today all 197 members of the United Nations have signed it. It is the very first international treaty to achieve such unanimity. Without the treaty, by 2060, 2 million more people each year might have gotten skin cancer, and entire ecosystems could have been damaged due to the loss of up to 60% of the ozone layer. But because of the Montreal Protocol, industry identified and produced chemicals with safer properties, and today humans use 80% less of the substances that damage the ozone layer. So world cooperation based on scientific data is actually restoring the Earth's ozone. Ozone is coming back. Basic scientific research and the pure joy of discovery identified one of the Earth's most urgent problems and offered the world a solution. Science works. Now that's poetry.
Yep. Science works.
Sunbathing in the...
Okay, now let's find out what happened. Okay, because of the Montreal Protocol, let's find out what happened to the holes in the ozone layer. I think.
Sunbathing in the open air. Since the 1980s, we've known that it's dangerous to your health because of damage to the Earth's ozone layer. There are huge holes in the ozone layer above both poles, but especially over Antarctica, that also affect Australia, Canada, and Northern Europe. Without the protective ozone layer in the stratosphere, that's at an altitude of around 20,000 meters, harmful ultraviolet rays reach the Earth's surface unfiltered. The result, anyone who goes around unprotected risks cancer and eye problems. That was behind the global ban on ozone killers such as chlorofluorocarbons 25 years ago. Whatever happened to the holes in the ozone layer? The ban on CFCs allowed the ozone layer to recover, but progress was still slow. Above all, CFCs from aerosol cans, refrigerators, and air conditioning have already done great damage to parts of the ozone layer. And continue to do so, because they're very durable and destroy the ozone in the stratosphere even after decades. Especially at high altitude temperatures of below -80 degrees Celsius. That's why holes in the ozone layer get bigger in the winter and shrink again in the summer. Climate change can also hinder the regeneration of the ozone layer because large amounts of carbon dioxide in the atmosphere prevent warm air from climbing. That means the stratosphere remains cool in the summer, even as the Earth's surface warms up. Scientists think it could take another 5 to 6 decades for the ozone layer to recover fully.
Let's hear that last part again.
Amounts of carbon dioxide. Climate change can also hinder the regeneration of the ozone layer because large amounts of carbon dioxide in the atmosphere prevent warm air from climbing. That means the stratosphere remains cool in the summer, even as the Earth's surface warms up.
And do you remember a tweet that Trump made I don't know how long ago? It's too cold. It's so cold. Something like, it's so cold. It's cold here. We need global warming. Well, he should watch this video. Well, let me try that again. He should watch this video. Because I don't think global warming's, because I don't think it's working at all. Because it's not working. Because his idea of global warming is not working. It's just his idea of trying to make the Earth warmer is not working. It's the opposite. If I'm understanding it correctly, that is. I'll admit that I'm wrong if I am, but unlike me, Trump will never admit that he's wrong. Let's continue with this.
Scientists think it could take another 5 to 6 decades for the ozone layer to recover fully.
So take this into account. Oh, globally. And go to www.ideasforacoolerworld.org for more idea. Let me do that real quick. Oh, it's already right there. Alrighty. Wait a minute. So hold the phone. Are these? I'll find out later. Because we're almost done anyway. Now, this is your
protecting.
Now this is your task right here. Now this is our task. Your task. My task. All of our tasks. This is our wait, let me rephrase that. This is your duty. This is my duty. This is all of our duty to protecting the ozone layer. So let's see what that duty. So let's see what that duty is.
Protecting the ozone layer, our duty.
Hello ladies and gentlemen, I'm Professor Waldorf, and this is my assistant Fabio.
Ciao.
Today we would like to take a few minutes of your time to talk about the ozone layer.
L'ozono.
Now for those of you who don't know, the ozone layer is a thin shield in the sky that protects life on Earth from ultraviolet rays. Much like umbrellas protect us from the sun, the ozone protects the Earth and its inhabitants. In the 1980s, scientific discoveries showed that the ozone layer was being harmed by human impact and slowly depleting. This depletion is extremely dangerous. Too much ultraviolet rays can have bad effects on our health. It can cause skin cancer and eye damages.
Che tristezza.
Every year, a hole as large as the USA develops in the ozone layer over the South Pole. In Antarctica, another hole develops each spring over the North Pole. In the Arctic. And there are signs that the ozone layer is getting thinner all over our planet. You may be asking yourself, why is this happening? Well, the explanation is not so complicated. You see, the main factor causing the depletion of the ozone layer is the emission of certain types of gases called CFC gases. These gases can be found in products we use every day. They are emitted by fire extinguishers, refrigerators, air conditioners, spray cans, and so forth. As these gases are released, they go up to the stratosphere and convert the ozone into oxygen. This causes the heating of the Earth as more UV rays pass through. Not only are those gases harming an essential component of our well-being, the ozone, but they are also affecting us directly, as they are dangerously hazardous.
Mamma mia.
At this point, you should be asking yourself, what can I do to make a difference? Well, once again, the answer is not so complicated. Fabio. Out of my chair. There are many actions you can take to help protect the ozone today. For instance, instead of riding a car to your destination, take your bike. Instead of leaving the air conditioner on for long periods of time, switch it off for a while. You can always turn it back on later. Other actions you can take include switching to stick deodorant, as spray cans are harmful to the ozone. You can also turn down your fridge when traveling, and carefully buy ozone-friendly products, which can now be found almost everywhere. Well, ladies and gentlemen, it was a true pleasure talking to you all. I hope you know that if you try, you can make a real difference, and do your part in protecting our Earth.
Addio, miei amici.
Bye, Emery Rick. Or Tada. Thank you for watching. for watching. Spring 2014 Physics 1930, Dr. Allen. Okay. Still a nice background, right? Okay. Okay. Now let's. Now that we know how to protect. Now that we know now that we know about the ozone layer, how to protect. What's damaging it, and how to protect it. It's yours, mine, and all of our duty to preserve it. After all, like in that one video, we don't want to live in a world where crops can't grow, environmental damage is high, and we're more likely to get skin cancer from high sunburns. Now before I close out this video, let's learn more about the International Day for the Preservation of the Ozone Layer. That's held every year on September 16th. Just a minute. Here we go. I got it. So, let's first start off with this. So the International Day for the Preservation of the Ozone Layer is observed annually every year on September 16th. So in more contrast, what is the ozone layer? Well,
the ozone layer, a fragile shield of gas, protects the Earth from the harmful portion of the rays of the sun, thus helping preserve life on the planet. The phase-out of controlled uses of ozone-depleting substances, and the related reductions have not only helped protect the ozone layer for this and future generations, but have also contributed significantly to global efforts to address climate change. Furthermore, it has protected human health and ecosystems by limiting the harmful ultraviolet radiation from reaching the Earth.
Well, now you know. Also, I think this is this year's theme.
Ozone for life. 35 years of ozone layer protection.
And there's a website you can go to right here. This has the same text as the one before. You could here's some down. You could take a look from the years 2020, 2019, 2018, 2017, 2016, 2015, 2020, 2006, 2014. You can look at everything from here. Well, going through all that would just take me a long time. So let me just do it this. Let me just give you the Let me just give you the link to the website.
https://ozone.unep.org/ozone-day/ozone-35-years-ozone-layer-protection.
I hope you got that because I couldn't hear a thing. Here's some download links. UN Secretary General message. World Ozone Day Girl and Father. World Ozone Day Girl and Pinwheel. World Ozone Day Boy and Dandelion. World Ozone Day Girl and Kite. World Ozone Social Media Pack. This is Espanol. Yep. There's some activities by the events listed have been organized independently by the
Activities by ozone stakeholders. The events listed have been organized independently of the Ozone Secretariat and UNEP.
You can learn more about that from the website. There's even a quiz you can take about World Ozone Day. Please select your ozone quiz language. I'm not gonna do it. Not because I don't think we're gonna not because I think I'm gonna flunk it, but the main reason is because But the main reason is because we're short on time. That's why. So if you want to learn more about that, so if you want to go to this website, you can. Just remember that link. I might even provide it in the description section. Anyway, let's learn more about this.
Background. A number of commonly used chemicals have been found to be extremely damaging to the ozone layer. Halocarbons are chemicals in which one or more carbon atoms are linked to one or more halogen atoms, fluorine, chlorine, bromine, or iodine. Halocarbons containing bromine usually have much higher ozone depleting potential, ODP, than those containing chlorine. The man-made chemicals that have provided most of the chlorine and bromine for ozone depletion are methyl bromide, methyl chloroform, carbon tetrachloride, and families of chemicals known as halons, chlorofluorocarbons, CFCs, and hydrochlorofluorocarbons, HCFCs. Vienna Convention for the Protection of the Ozone Layer. The scientific confirmation of the depletion of the ozone layer prompted the international community to establish a mechanism for cooperation to take action to protect the ozone layer. This was formalized in the Vienna Convention for the Protection of the Ozone Layer, which was adopted and signed by 28 countries on March 22, 1985. In September 1987, this led to the drafting of the Montreal Protocol on substances that deplete the ozone layer. Montreal Protocol. The principal aim of the Montreal Protocol is to protect the ozone layer by taking measures to control total global production and consumption of substances that deplete it, with the ultimate objective of their elimination on the basis of developments in scientific knowledge and technological information. It is structured around several groups of ozone-depleting substances. The groups of chemicals are classified according to the chemical family, and are listed in annexes to the Montreal Protocol text. The protocol requires the control of nearly 100 chemicals in several categories. For each group or annex of chemicals, the treaty sets out a timetable for the phase-out of production and consumption of those substances, with the aim of eventually eliminating them completely. The timetable set by the protocol applies to consumption of ozone-depleting substances. Consumption is defined as the quantities produced plus imported, less those quantities exported in any given year. There is also a deduction for verified destruction. Percentage reductions relate to the designated baseline year for the substance. The protocol does not forbid the use of existing or recycled controlled substances beyond the phase-out dates. There are a few exceptions for essential uses where no acceptable substitutes have been found, for example, in metered dose inhalers, MDI, commonly used to treat asthma and other respiratory problems, or halon fire suppression systems used in submarines and aircraft. In 1994, the United Nations General Assembly proclaimed September 16 the International Day for the Preservation of the Ozone Layer, commemorating the date of the signing, in 1987, of the Montreal Protocol on Substances that Deplete the Ozone Layer, Resolution 49/114. Implementation of the Montreal Protocol. Implementation of the Montreal Protocol progressed well in developed and developing countries. All phase-out schedules were adhered to in most cases, some even ahead of schedule. Attention focused initially on chemicals with higher ozone depletion potentials, including CFCs and halons. The phase-out schedule for HCFCs was more relaxed due to their lower ozone depletion potentials, and because they have also been used as transitional substitutes for CFCs. The HCFC phase-out schedule was introduced in 1992 for developed and developing countries, the latter with a freeze in 2015, and final phase-out by 2030 in developed countries and 2040 in developing countries. In 2007, parties to the Montreal Protocol decided to accelerate the HCFC phase-out schedule for both developed and developing countries. Universal ratification. On September 16, 2009, the Vienna Convention and the Montreal Protocol became the first treaties in the history of the United Nations to achieve universal ratification. Kigali Amendment. The parties to the Montreal Protocol on Substances that Deplete the Ozone Layer reached agreement at their 28th meeting of the parties on October 15, 2016 in Kigali, Rwanda to phase down hydrofluorocarbons, HFCs.
Excuse me. Alright, so we can learn more. And this is what Antonio Gutierrez said about this. Here, this is his quote. Oh wait, let's do this first. How to observe today the International Day. How to observe the International Day for the Preservation of the Ozone Layer.
How to observe. Despite the good news, ozone depletion is reversible, there are still concerns. For this reason, the UN and other environmental groups promote awareness for protecting the ozone layer. On the International Day for the Preservation of the Ozone Layer, educators around the world organize activities in their classroom that focus on the importance of the ozone layer. Other organizations promote ozone-friendly products, distribute public awareness posters, and hold a variety of events geared towards saving the ozone layer. If you want to get involved in the International Day for the Preservation of the Ozone Layer, educate yourself on its importance. Try to imagine what our Earth would be like without the protection of the ozone layer. Learn why it's important to protect yourself from UV rays.
That's something Trump needs to do big time, and maybe Biden. Or you to educate Trump. And he's not doing a very good job of environmental protection, so that's a very good reason why Trump needs to go. So now here's the quote.
Let us take encouragement from how we have worked together to preserve the ozone layer, and apply the same will to healing the planet and forging a brighter and more equitable future for all humanity. Antonio Guterres.
Yeah. So I could have, you know. You know, here's the funny thing. I could have done this next year, but due to the fact I could have done this video next year, 2021, but due to the fact that how important this election is, I decided to do it this year because of, you know, how bad Trump's environmental regulations are, how he's destroying the planet. It's just can't stand it. Anyway. Anyway. I feel like I've forgotten. Hold on, I feel like I've forgotten. Hang on, I feel like I forgot. Oh. Excuse me for just a second. Please. All right, I'm back. Sorry, I had to deal with something really quick. But anyway, I'm gonna close out this video now. So thanks for watching this video. Now don't forget to like, comment, subscribe, and leave a comment down below. And if you can, share this video. Share this video with as many people as you can. Friends, family, complete strangers. The possibilities are endless. Also subscribe to my channel with as many people as you can, friend. And then share my channel with as many people as you can. Friends, family, complete strangers. The possibilities are endless. Help this video reach 100 or even 1,000 plus views and a lot of likes. I would really appreciate that. And remember, the fate of the world is in yours, mine, and all of our hands. That message was to the American people because of the election of 2020. We need to decide on a president. We need to decide on a president. We need to kick Trump out of office and replace him with, it doesn't matter who, Howie Hawkins, Joe Biden, but we need to make sure that Trump doesn't win. That's the most important part. Even if you have to convince his vote, even if you have to convince people, even if you have to convince those who are going to vote for him to vote for someone else other than him. Because remember, the fate of the world rests on our shoulders. Now I'm going to close out this video with a song, with a song called the Ozone Song. With the Ozone Song by the UN Environmental Program. So I hope you enjoy the song. And until next time, this is Jeffrey Bartol, signing off.
C. For photosynthesis need UV, but too much bleach is out of green and damages our DNA. Yes, we've been having a hard time for many years, but now let's celebrate, whoop and cheer. That big Antarctic ozone hole is healing now thanks to the Montreal Protocol. Healing thanks to the Montreal Protocol. Healing thanks to the protocol. We're delightful, fighting fit, floating phytoplankton, living in the big wet sea. Tiny, mighty, thronging, thriving, feisty phytoplankton, dancing nature's choreography. You naughty humans sprayed ozone depleting stuff, such as chlorofluorocarbons, into the air enough to interfere with ozone that shields Earth from UV rays. But international action has succeeded in reversing ozone's decay. Hooray, hooray, hooray! We're delightful, fighting fit, floating phytoplankton, living in the big wet sea. Tiny, mighty, thronging, thriving, feisty phytoplankton, dancing nature's choreography. UV radiation splits molecules in stratosphere. O2 oxygen divides, quickly recombines, but here, 1 in every 500,000 ends up as ozone. O3, the conquering hero, from UV shields our planetary home. Is home, her home, my home, your home, everybody's home. We're lights down